Hello everybody, welcome to 7-3 Graphing Sine and Cosine Functions. Our learning objectives today are to first, identify key features of the sine and cosine functions in the coordinate plane, and then we're going to evaluate amplitude, period, frequency of sine and cosine functions and solve real world problems including those functions. All right, so let's start off by understanding what a sine function is and how it would look on a graph. Let's start with the very basics and the fundamentals. So if we look at this little chart here that I've made, looks like a circle with a bunch of colors. All right. So consider f of theta equals sine of theta. So in other words, where our x would normally be here, we're using theta instead because we're referencing our angle measures, right? In terms of pi and our radians. So let's just look at this. Let's start at 0, okay? Well, first of all, f of theta is going to be like your y value. So what happens to the y value as theta increases? In other words, let's think of like a normal graph, right? If you have a linear graph, as x increases, y increases at the exact same rate, right? That's what a linear function is. As the x values increase, the y values increase additively, right? It's a first degree function. On a second degree function, right, or an exponential function, what happens is our rate of change is, instead of being linear, is now exponential, which means that we are multiplying the rate of change each time, or our common ratio is a multiplication, right? It's not just an addition. Well, in this case, you're going to notice that this doesn't follow that kind of pattern at all, right? There is no as x does this, y does this. It's going to actually work more in a cycle, right? So if we start off here, right, our theta value, or x, if you want to call it x value, that's fine too, but we don't want to think of it as x. We want to think of it as our theta is increasing, right? In other words, as the measure of our degree is increasing. So if we go around this circle 6 times, we're still increasing the amount, even though we aren't like moving on the circle, right? The amount of degrees of the angle is still increasing. So if we start here, right, at the very beginning, as we go from 0 to pi over 2, or 90 degrees, right? As we go from there, we're going from where y equals 0 to y equals 1, right? And then from here, we're going from pi over 2 down to pi, and we're going back down to 0. So we're going from 1 to 0, and then to 3 pi over 2, we're going to negative 1, right? And then back up to 0. And remember, all these I'm referencing the y value, right? Y value starts at 0, y value goes to 1, back down to 0, to negative 1, to 0, to 1, and you get the idea, right? It's going to keep switching over and over again, right? And this is going to happen infinitely. It's going to keep waving, right? This is why we call sine a wave. You've probably heard this before, because what happens is it goes up to 1, then back down to 0, and then down to negative 1, and then back to 0. And I can just kind of draw this real quick, and we're going to go over this, but like you can kind of imagine the idea that if we have like a graph, right, where this is like this, let's say this is y equals 0, right, this piece here, then what we're actually talking about is we're going to start here, we're going to go up to 1 and negative 1, and we're going to go up here, and then we're going to go back to 0, and then down to negative 1, and then back up to 0, and the wave is just going to literally continue like this forever, right? It's going to keep going up and down, and this is what a sine graph looks like. So let's go ahead and actually graph this real quick, just so I can show you. So let's go to Desmos, and I've already actually populated the sine graph here. And you'll notice this is exactly what it does, right? We start at 0. At pi over 2, we go up to 1. We go to pi here. We go down to 3 pi over 2, where the negative 1 comes into play. And you'll notice that this continues forever, right? Well, this is exactly how a sine function works. It's also how cosine function works, but cosine works a little bit differently. All right, so let's actually start talking about some of the key terms, right? So first thing to notice is that these, I'll pop up cosine here just to show you, it's kind of the same, right? But these kinds of graphs are what are known as periodic functions. And the reason why they're called periodic functions is because they work in cycles where the outputs frequently repeat, right? You'll notice the outputs here are 1, 0, negative 1, 0, 1, right? The outputs are continuously repeating. So that's why it's called a periodic function. All right, so let's look into the key features of our graph here. So if we just look at our graph of sine x, right, I'll put this one back here. There's a few key features here, all right? Now, one thing I did is you'll notice that one thing you can do on Desmos or on your graph is change the step feature here to pi over 2. And this is going to turn these numbers here on the x-axis into pi values as opposed to just normal like digits or integers, right? We can change that. So that's kind of useful. All right, so a few key terms. First one is midline. The midline is the horizontal line that represents the center of the graph, right? So in this case, it's just our x-axis. You'll notice that our x-axis is the same distance from our maximum values as they are from our minimums, which makes sense because they're both just 1, right? We go up to 1, we go down to -1. So this center line here is known as our midline, okay? So amplitude is the distance from the midline to our minimums and maximums. So in this case, our amplitude for a basic sine graph is just 1, because we go from 0 to 1 for our maximums, and we go from 0 to -1 for our minimums. So the amplitude is the effect to which this could be stretched, right? The amplitude will be the graph stretched a little bit, and we'll talk about that a little bit later, but that's essentially what it is. Our amplitude is the absolute value of like the minimum and maximum that these things go. And then the period is the length of each cycle, okay? And this can get a little bit confusing, but if you think like, okay, we start at 0, we go up, and then we go down, and then we go back to 0, right? And then we go up and then down and then back to 0 again. So the total amount of the period of a sine function, right? We go up and then we go down and then we go back up. This takes an entire cycle, takes 2 pi, right? That's the distance of one entire cycle on a standard sine graph, right? So the period of this function would be 2 pi, right? So we'll like I said, we'll talk about that a little bit more, but that's kind of the idea. So if we look at our graph here, I sketched it, which, you know, always take that with a grain of salt, but our midline is y = 0, right? It's our x-axis. That makes sense. Our amplitude is 1, because here you'll notice in the orangish color here, you'll notice that we go from 0 to 1, and then we go from 0 to -1, right? But both of which are a distance of 1, right? Our period is 2 pi, because that's the time it takes to get from our original spot all the way back to our original spot, right? Where we have done one full cycle of this. You'll notice on here I've graphed 2 periods, right? We've gone from here to here, and then we go from here to here. All right, our maximums are located at -1.5 pi, right? So in other words, maximums are here and then here, and you notice that they're 2 pi apart, right? Which makes sense, right? Everything is 2 pi apart because that's the length of the period. And then our minimums are at -1/2 and 3 pi over 2, right? -0.5 pi and 3 pi over 2, and those are also 2 pi apart, right? So our minimums and our maximums are always 2 pi apart. And essentially the minimums and maximums are going to happen at those like half pi steps. In other words, pi over 2, 3 pi over 2, -pi over 2, -3 pi, right? It's all of those like half, 1.5, like those pi's. That's where the minimums and maximums happen on a sine graph. Okay. Now, the reason why I mentioned that is because, well, what about cosine? Now let's go and do this real quick. I just want to show you something. So I'm going to populate cosine real quick. And now I'm going to get rid of sine, right? And you'll notice that, well, okay, let's go back here, right? Look at this first point. Let's look at the y-axis. You'll notice that cosine starts at 1, right? Well, sine started at 0. Actually, if we took this sine graph and we moved it to the left by an amount of pi over 2, so in other words, if we took this whole thing and we shifted it pi over 2 to the left, they would sit on top of each other, right? Sine and cosine are very, very similar in that way. The only difference is that the cosine graph is the sine graph, just shifted a little bit to the right, right? Everything, or shifted to the left, I'm sorry. The cosine graph is shifted just a little bit to the left. But so all that's going to change is where our maximum and minimum values are. It doesn't change the period. It doesn't change the amplitude, right? It doesn't change the midline. Those things don't change. The only thing that changes is where our values are. So in other words, where are we at 1? Where are we at 0? Those things are going to change slightly, right? And we can talk about that. So the graph of cosine x is the graph of sine x, but shifted pi over 2 to the left, right? We just said that, like it's shifted literally half pi this way. All right, so the midline is still y = 0. The amplitude is still 1. The period is still 2 pi, right? If you notice here, like if we get rid of the sign here just for a second, we start at 1, we go down to -1, and we go back up to 1, right? But the distance from 1 to 1 here is still 2 pi. So the period's still 2 pi, right? The maximum, instead of it being at those half intervals, are now at the whole number intervals. So instead of it being half pi and -half pi, we're now at negative pi and pi, right? So our minimums and maximums are going to be at those whole numbers instead of the half numbers like they are for sine. All right, so I think that that's kind of completing the concept of what the difference between sine and cosine are, and then what the basics of the graph are, like just from the parent function perspective. So let's talk about frequency. All right, so frequency in the real world is how often something happens, right? If you say something happens frequently, it means it happens a lot. If you say something happens infrequently, it means it doesn't happen very often. Well, it's kind of the same idea behind any kind of periodic function, right? For sine and cosine x, a period happens once every 2 pi. So the frequency is 1 over 2 pi. In other words, every 2 pi, we have one cycle, right? That's what this means, one cycle per 2 pi. The frequency can be thought of as the reciprocal of the period, which makes sense, right? Because this is the multiplicative inverse, right? We put the 1 over the 2 pi. So frequency is kind of the reciprocal of whatever the period is. So when we talk about frequency, we're saying how often it happens. When we talk about, or how often our period happens. And then when we talk about the period, we're talking about how long each cycle is, right? All right. So let's talk about transforming amplitude and period. So we're going to talk very basically about transforming just specific parts of our function today. We're going to go into phase shifts and all of those things in the next lesson. But for today, we're just going to talk about these two letters. We're going to talk about A and we're going to talk about B of both sine and cosine. So let's go back to our graph here, and I'm going to pull these ones up, okay? You'll notice that I have A and B set to 1, so this looks exactly the same as this. So it'll just sit right on top of each other, right? You'll just notice the color changing. Okay, so let's talk a little bit about what these do. So A, this number here out in front, so A times the function, right? A affects the amplitude. And of course, the amplitude is how high and how low it goes. If the amplitude is 2, it's going to go twice as high and twice as low, right? In other words, the amplitude will spike at 2, and it'll go all the way down to negative 2, right? So the absolute value of A is greater than 1. The amplitude stretches. So let's look at that, okay? Let's take A, and let's make it 2. Well, that was going a little bit more. You notice how before, I can post this one here, right? The blue is the original function. When A equals 2 is us stretching the amplitude, you'll notice that the period is still the same, right? Everything is still the same. The only difference is it goes twice as high. Or you could say the y values increase twice as fast, right? Like it's going all the way up here. All right, so when A is between 0 and 1, the amplitude compresses, right? So in other words, just think about what this would, why did I touch B? All right, here we go. So this is 1, right? Watch what happens as I go down. Let's go to 1/2, right? You'll see how it pinches against the x-axis, right? It compresses against the x-axis. Now, you can kind of tell how that makes sense, right? If 2 raises it to be, if this is getting bigger and bigger, then this is going to be more and more close to the x-axis, where when you approach 0, right, let's get to 0.1, it almost looks like it's riding the line here, right? Like it's barely going up and down at all. In fact, 0 would be a line, right? Okay, so let's go back to 1, because now we're going to talk about, okay, we talked about what happens if it's less than 1, what happens if it's greater than 1. Obviously, if it's 1, it's just the standard function, right? But if it's negative, well, it does what it always does in this case, right? We're going to reflect over the x-axis. So let's go to -1 and just compare. It's actually going to look kind of cool, right? Yeah, this is our negative graph here. So you'll notice that when we start at 0, instead of going up to 1 at the beginning, now we go down to 1 at the beginning, right? And you'll get this really cool looking graph here. It looks kind of like a DNA strand or a double helix, right? But that's what it being negative does. Now, I mean, if it's -2, it's going to not only flip, but these things are going to get bigger faster, right? So let's go to -2, just to show you it does both, right? Now we're negative, and we're stretching to an amplitude of 2, right? So that's what A does. If you multiply a number by the function, it's going to increase the amplitude. If that number is negative, it's going to increase it and flip it. If the number is a fraction, like less than 1, then it's going to make it even smaller, right, than before. So that's what A does. So now let's talk about B. So B affects the period / frequency, right? Because anytime you talk about a period, you're going to talk about the frequency. Anytime you talk about frequency, you're talking about the period of the function. So as B increases, the frequency increases at a rate of B. the period length decreases by a rate of b, right? So here, just kind of look at this more of a formula. The frequency is going to be the square root of b over 2 pi, right? So if you think about this, if the period is 2 pi, right, what we were saying before is, okay, this is happening once every 2 pi. If we increase the frequency, it would happen 2 times every 2 pi, right? So you're going to get twice as many waves. If b is 3, you're going to get 3 times as many waves, right? And then the period, of course, is going to be, okay, the period is 2 pi, and this is normally 2 pi divided by 1. If b is 2, this is going to be 2 pi divided by 2, right? So it's the same concept, right? The period is half as long, right? It's not taking as long to get from the 0 up to the 1, back down to the -1, and then back to the 0, right? It's going to take us half as long to do that. So this is saying frequency says it's going to happen twice as often. Period says it's going to take half the time, right? And those both mean the same thing, but you're just looking at it in a slightly different fashion. So that's the reason why both of these terms are very critical to understanding, because we're going to use both of these going forward quite a bit. So if b is negative, the graph reflects over the y-axis. You're not going to see that too often, but it is technically true. So let's go ahead and reset our a here back to 1. And now let's go ahead and take a look at this. So you'll notice that as b, let's take b and let's double it. Okay. Now this looks like kind of a lot. Let's go ahead and get rid of this for 1 second. Okay. First of all, you'll notice we start at 0, but now we go up and then down and then back up. And this only took pi this time, right? Normally it takes 2 pi. So we went through an entire period, right? Or an entire cycle in half the time, right? So this period is half as long, but the frequency, if you want to look at it, okay, how many times did we do this in 2 pi? Well, we did it once, we did it twice, right? So the period is twice as much, the frequency is twice as much, the period is half as long, right? Because it took us half the amount of time to get to the same place, right? So that's what happens if you want to triple it, watch, you'll get even more waves, right? You see, as we approach, these numbers get bigger. You can see how many more waves we get, right? This is 10 times the waves. If we counted this 1, 2, 3, right, we would get 10 waves in the same amount of time, right? So that's what b affects, right? And then if you wanted to see the negative, flipping it over the axis just for fun, right? Well, first of all, let's also talk about what happens if it's, right? If we go to 0.5, that's kind of the opposite of 2. It's going to take twice as long, right? Like let's go all the way over here. Where's 4 pi? Right here. You'll notice that it takes all the way to 4 pi for 1 period now. The frequency is now 1/2 over 2 pi, right? Which is the same as basically saying it's going to take twice as long, right? Or it's going to happen half as often, right? It's the same concept. If you go negative, just to show you this, right? Let's go -1. And then just pull it up compared to this standard sign, right? You see that it's also, right? It's reflected. It actually looks like it's reflected down, but it's actually reflected to the left. It looks like both, right? Actually, what's interesting is because you can reflect both of these, if I make a -1, watch what happens. It's actually just kind of neat, in my opinion. Goes right back to normal, right? Because now you're reflecting it over the x and the y-axis. So it looks like it's exactly the same because effectively it is, but it's actually just flipped over both axes. So it kind of just resets itself. So just kind of a neat little thing there. I thought I'd show you. But that's the idea, right? A is going to affect our amplitude. B is going to affect our frequency/period. And that's kind of it. So let's go ahead and look at one real quick. Okay, if we have f of x equals -3 times the sine of 2x, well, let's think about what that would mean. Okay, and then we'll graph it to prove it. Well, -3 means first of all, it's negative, so it's going to flip over the x-axis, right? The 3 means it's going to stretch from 3 to -3, right? It's going to stretch that amount, the amplitude up and down. And then the 2x is going to make us that it's going to happen twice as often, right? So in a 2 pi period, we're now going to have 2 full cycles, right? Or the other way you could look at it is it's going to take half as long. So in other words, each period is only going to be pi length, right? So there's 2 ways of looking at it. So the 3 will stretch the graph vertically. The amplitude will range from -3 to 3. That's what we said. The negative will reflect it over the x-axis, okay? And then the 2 means that the frequency will double, the period will be half. The frequency is now going to be 2 over 2 pi, which is the same as 1 over pi, right? And the period is going to be 2 pi over 2, which is the same as pi, which is what we said, right? It's only going to take pi time now in order to get there. So let's go ahead and do this. So it was -3 and 2. Yeah, let's do it. So -3 and 2. All right, and that's exactly what we said, right? Just look at this. So we start at 0, we go down to -3, up to +3, right? We reflected. You can see how this starts by going up and this starts by going down, right? So we actually reflected over the x-axis as well. And we, instead of now, okay, this is normally, we go up and we go down and we end at pi. Normally when we go up and then we go down and then come back in the middle, it takes 2 pi. So we're literally doing 2 cycles, right? In the amount of time that it would normally take us to do 1. So our frequency is doubled, our period is cut in half. Guys, that's it. All right. Now you can take this information, jump into some problems. This is everything that when it comes to problems with these are going to be evaluating data and just looking at what the data means, right? Understanding how we can utilize these different shifts, these different amplitude and period changes. It's just going to take some doing some problems at this point, but this is really all of the fundamentals that you need to be able to jump into those problems at a really high level. So, all right, that's it. So quick recap. We talked about a sine function and what it means to be periodic. We then went over the key features of sine, including the midline, which is the y = 0 in this case, amplitude and period. And then, of course, we talked about frequency and how that relates to period. All right, and then we talked about how A and B affect our amplitude, our period, and our frequency. And then we did an example. And that's it, guys. A little bit less conceptually challenging than the last 2 lessons, I think. And for our last 2, we're going to talk even more and go even more in depth about how we can shift our graph around. And then we're also going to talk about the other 3 or the other 4 trigonometric ratios and functions that we didn't talk about today. So that's going to be our last 2 lessons here. And that'll be it for our first unit of trig. So I will see you in the next video.